In the last few months, I spent way over 2,000 hours building custom AI agents solutions for different organizations in different verticals and industries. And in this video, I'm going to uncover what truly matters when building an AI solution or an agent for your organization. I'm going to uncover what are the best practices to follow, what mistakes and challenges that we faced, and how you can avoid them, and how to go about building, implementing, and adopting an AI solution or an agent for your organizations that align with your top tier business objectives and will give you an edge in your marketplace. So let's just go straight in. Now, why should you care? We've been building this for quite a while. We started as a data analytics firm. We are still a data analytics and AI firm. As I like to say it, we drove way over plus 20 million in pure value, aka cash collected for different organizations, just by bridging the gap between business, data, and AI. And yeah, in this video, as I said, I spent way over 2,000 hours building custom AI solutions and agents, and here are some of the best practices that I personally faced and how you can go about building a AI agent or a solution for your organization that will give you an edge in your marketplace and of course increase your revenue, increase your profits, save you time and save you cost on labor. So the first thing is thinking in terms of data flow. Now, when building a custom AI solutions, a lot of companies or people on YouTube, because I watched a couple of YouTube videos, don't think about scalability and consistency, right? You've probably seen some YouTube video talking about specific in AI solutions, which seems good on a video. It's a good enough solution or a demo or an MVP shown in a video. But when you try to implement that exact way of building it, either that be an agent or a solution, AI solution, whatever it is, it simply doesn't work, right? It looks good on a video. It's good if you show it on a YouTube video, show it like on a meeting for a quick MVP, but that's basically it, right? It doesn't really work in production, aka in your day-to-day life. Now, why is that? AI loves simplicity. 99% of these solutions are pretty much complex. They think that AI agent has to communicate with other AI agents, then they need to grasp the context. It basically gets so complex that AI simply doesn't follow it anymore and just spits out useless stuff, right? That's why I said AI loves simplicity. Now, AI model will perform 10 times better when they need to have, okay, they need to make two choices opposed from making 10 or 5 decisions that are barely distinguishable between each other. And for that reasons, you need to think in terms of data flow, aka sequential architecture, which basically means how is data passed from one process to the another, which is here's the basically a picture. User input, process, and user output, meaning user inputs a specific type of information, then the information is processed, either that be formatted, AI, whatever it is, and that information spits out to the next tool or to the final input back to the user, right? But most people are building like all in one solutions. They think that they need to have multiple dozens of AI agents, multiple tools connected to each other. They need to think that AI solution has to do everything all in once. That's why they don't really know how data is getting passed through the system, which basically results in very inconsistent results and at the end unreliable. And that's why it doesn't work at the end. Now, what is the really correct way? When we start building custom AI solutions and agents, the first best way to go about building it is to map out your data flow. That's why we call it data flow here. But in short lines, you map out how the whole LLM infrastructure should work. Basically, here is the user input. Okay, when we get the user input, where does those information, okay, those query go to? Does it go to the LLM? Does it to go to a specific tool? Where does it go, right? You basically map it out. Now, here is a quick video. It's not a video, it's just an image of how we go about mapping this out. It doesn't need to be pretty. You just open up a quick flowchart tool and just map it out. Let's say user input. You have here a chat text API. It goes to the orchestration agent. Basically, orchestration agent classifies it per operation. Basically, it breaks down user input and simplifies it, either that be to, and then routes a specific user input to an SQL agent, RAG agent, whatever it is. And here's how the SQL agent works. Turns the user input to a query. It's connected to the knowledge base, which has the context, or how to navigate throughout the database in BigQuery, validates the SQL. If the SQL it's not valid, it retries it again. Once it's valid, formats the final output, right? And that's how it goes about it. Basically, that's how we map out the whole LLM before you even start building it. And why this is important, I'm gonna go now in a second. The second point is simplifying it. The goal and the biggest challenges that companies are facing right now is consistent and reliable results with AI, right? AI sometimes will spit something completely irrelevant, but sometimes it will be good enough, and sometimes it will be perfect. But you will never know 100% when that will happen, right? And to minimize inconsistent results, you need to basically simplify the whole process rather than having remember the previous step that I said, LLM loves simplicity, meaning LLM will 10 times work better when they need to make 2 or 3 decisions, and those 3 decisions are clearly distinguishable between each other, rather than they need to, when AI is in charge of, I don't know, so many stuff like calling the tools, making 10 decisions, and they're like barely noticeable between each other. It's much more harder. That's why you need to simplify it, right? Meaning you just go and break down what you want to achieve in a simple sequential steps, right? Let's say, okay, I want AI to go to the SQL and create a query and provide me with the output, basically an SQL agent. And here's a quick SQL agent that I just showcased you in a short lines, right? Basically, that's how we basically mapped out our SQL process, like SQL agent, AI, whatever you want to call it. And we simplified it at the start so we understand how the data is passed through the whole system. And why this is helpful is because it's easier to build. It's much more easier to build. We know exactly what gets passed around. Faster development time, consistent results, context, meaning context gets AI loves context, which basically means that if a user asks some specific questions and AI is in charge of creating a certain output, it has to understand why, right? It has to understand why. And because it's a sequential, because one output from one specific process, it's another process input, meaning output, input, and so on and so forth, the context gets passed around. It's easier to debug because we understand where the exact issue is if there is an error, and we understand what tools do we need to use to go about building it. Do we need to use just no-code tools? Can we do it with no-code tools, even though we don't really build with no-code tools? Do we need to use strictly code, or how we go about it, or is it hybrid between those two development parts? So, in summary, before building out, literally just map out your whole data flow and simplify it, meaning you need to think in terms of how data flows throughout the whole system. So the next steps is chains versus agents. Now, or you can call this also workflows versus agents. These 2 separate things, which most companies and people trying to build AI solutions don't really distinguish between each other. And the first thing, let's say I'm just going to go quickly go through it. Basically, chains. A chain is a predefined structured sequence of steps where each step is dependent on the previous one. Unlike agents, chains follow a set path rather than making decisions dynamically. Literally what I said prior here above. Meaning here you have, let's say, user input, process 1 feeds to the LLM. Process 2 parses the specific LLM from the previous process and just takes specific chunk of the text, right? For an example, let's say a regex function, whatever it be. Process 3, though that's parsed text that we got from the process 1 is then passed around to the another tool, and then we can get final output, right? Basically, each process output is another process input, right? Very simple. And best use cases for chains are basically fixed sequences like transcription, summarization, sentimental analysis, static rule-based workflows, and of course follow a structured format, meaning step 1, step 2, step 3. Now, here you probably already heard about automations and processes. You can have chains, like workflows, not without AI or with the AI, right? Now, the limitations of chains are they are not adaptable. They cannot adjust dynamically, And if you want to make them trying to do that, you'll need to utilize logical functions like if else and so on and so forth. Now we have fails with uncertainty, meaning sometimes we'll just simply break because it misses specific input from a previous process. And there is no decision-making process, meaning chains cannot choose alternative path. They are basically strictly obeying the pre-written rules, pre-written steps. So basically, this is the explanation of the chains, aka workflows. Now, the agent is an autonomous system that can make decisions, take actions, and interact with external systems based on objectives and input data. Basically, it doesn't just generate responses, but also performs tasks dynamically. Meaning, let's say it receives an input or a goal, uses reasonings of what tool or what processes to do to call, interacts with specific tools, APIs, databases that we give him, agents, and iterates until we have the final result. Right? Here's an example: users interacts with an SQL agent. SQL agent has access to the database. It has access to the report generation. Basically, it's like another agent or another tool that if it calls, it will generate a report. It has a tool context, aka knowledge JSON file, meaning to understand how to navigate through the SQL database. It also has memory, basically context. Limitations of agents are simply they're more expensive, harder to control, meaning you don't have really control over it, meaning they are less predictable, and of course slower than agents because SQL agent has to utilize and analyze before conducting any type of action. Best use cases for agents are simply adjusting responses, meaning dynamically adjusting responses, AI orchestration and task routing, meaning it decides what specific tool, specific process is best to use, and agents decide which tool or sub-agents to call, which is basically that. And of course, used when logic is not static, meaning it analyzes, chooses best method, basically thinks rational, not in logical sense. Now, proposition. Here is no really right or wrong answer, but why I mentioned chains versus agents, because when you implement and you map out your data flow in the first step, you will understand where chains are simply better to use. You will understand what and where what steps agentic framework is best to use. Meaning each step is by mapping out, you will understand what specific framework to use and where and why, right? Before moving forward in the development. And the best way to start with this is to utilize the fastest and the simplest solution. Now, I like to utilize chains here because at the start, because we know and understand and we will have more control at the start, and it's easier to build upon it. Because if you utilize agents at the start, you're gonna be playing with very unreliable system because you didn't really prove it at the start yet. But if you utilize chains at the start, like a simple workflows, you're able to understand of what's good, how it works, is it working with chains? Because if it's not working with chains, it's not gonna work with agents. Best believe that. But that's why I like to utilize the approach hybrid, which is basically chains and agents together. You utilize agent to analyze and route requests, use chains for structured execution, right? Meaning, let's say agent decides if task requires SQL, API calls, task generations, what specific tools to use. Chain executes that specific predefined workflow, right? And this is just like a simple explanation between agents and chains. So keep that in mind. Now, context and memory. Now, if you want AI solution to perform consistently, it has to be always provided with the context to the end user is asking. You cannot expect that users to write and communicate with an AI in a direct jargon and a language that AI will know. Meaning, let's say a user might misinterpret or create some type of grammar mistakes. They might use specific jargon that's specific for that industry and for that specific role. And you cannot expect AI to know that, right? That means that AI, okay, has to have a context, okay, has to have memory to it, right? And the current bottleneck here is remaining memory without hitting the token limits, meaning, but there are ways to go around that using short, long summary, trimming memory sessions. You can check the LangChain documentation regarding that. But what I'm trying to say here that the context is super important to the AI. You cannot just expect to perform it with a simple prompt. And when passing, when I say and what I'm trying to get, what I'm trying to teach you guys or what is my point to bring across is when passing data around from system to system, from AI to an AI, from process to process, data has to be accurate, consistent, and reliable. And the best way to transfer it is using JSON, because AI simply loves JSON because it's structured, right? And plus it ensures consistency. And when providing context, let's say knowledge base, have it as a tool. Let's say in above example, we have an SQL agent, which is basically an SQL agent needs to understand of how to navigate through a database, right? And as a user, I'm not going to be like, yeah, give me give me the unique users from table XYZ. I'm not going to give that input. I'm going to be like, just give me the users that we have. Simple, right? And the AI needs to understand what tables to look for, especially if you have a database with multiple tables. Uh, and for one specific reasons, that's why you need to have, let's say, a knowledge JSON file. Let's say a JSON file which is basically filled with the definitions of the tables, the columns of of specific tables, when to use specific tables, specific acronyms, specific words, specific definitions. So when a user asks it, the AI SQL agent or whatever agent can go inside of the JSON file, understand it, and know how to navigate through a specific tool, right? So that's why the context always matters. The third point is only pass relevant information, meaning don't pass or save things that are completely irrelevant, right? The fourth point, don't include duplicate information. Just because let's say you talked to an agent and you mentioned a couple of stuff multiple times, which are basically the same, don't save it in memory. It's completely worthless, right? And now you can still, but you will basically hit the token limit, and it will be much more harder and much more expensive. You need to decide regarding that. And when building multi-agent systems, meaning that you have multiple agents and you have one big supervisor agent, you need to have a shared memory state, because separate will simply not work. So in short lines, what's the summary of this specific third point is basically to have an agent to perform a consistent and reliable result, you need to make sure it has context and it has memory. You cannot just expect to write a simple prompt to an AI agent or an AI, whatever it is, and it will output you what exactly you want. No, it doesn't work like that, right? Now, for point RAG and fine tuning. Now, I'm gonna probably get hate for this, but majority organizations have 10 times better and bigger chances of using RAG than think about fine tuning at the start. Fine tuning really makes an exception in only few cases. But when starting with AI and wanting to implement AI agents or solutions in your organizations, in your operational workflows, RAG is the best way to go about it, because fine tuning is expensive, it's hard to do, it requires a big experience, and I'm gonna go right now about how the comparison between those two. Now, let's say here we have RAG, speed to deploy is literally fast. You can spin up our RAG pipeline in literally a day. Fine-tuning model, weeks or months. Ease of implementation, cost, RAG, scalability, data needs, model maintenance. If you decide to do a fine-tuned model, every time you change something, it has to be redone again, basically retrained again. But with the RAG, you simply just, let's say you have a database, vector database with full PDF documents, you literally just can add another PDF. I mean, you need to vectorize it, you need to format it, you need to chunk it, and so on and so forth. But it's much more simpler and straightforward process. Handling new information, basically the same. Accuracy may hallucinate if info is in the database. Yeah, that's potentially true. Customization, that's probably more correct for fine tuning, meaning can generate highly specialized content. Use case examples, let's say for RAG, customer support, knowledge bots, search assistants. For fine tuning model can be, let's say, medical AI, legal document drafting, highly specialized writing, and so on and so forth, meaning something that AI has to know, right? You cannot, basically you need to learn AI on bunch of examples and use cases. Now, here are some of the real life examples of utilizing RAG or versus fine-tuned models. Let's say customer support bot, that's a no-brainer. You can literally just utilize vector database, Pinecone, filled with PDF files, FAQs, documentations for instant answers. For fine-tuning, this simply doesn't make sense because it's unnecessary, because it's handling unique conversational styles every time. For fine tuning, it makes more sense, let's say, for medical diagnosis AI, right? Because accuracy is 100% more critical, meaning fine tuning on patient data and medical text for high precision. Same applies for, let's say, personalized chatbot. Fine tune if the bot must mimic specific coaching methods, right? Here's an example of basically, and you can see it yourself, or you can pause the video of when to use RAG or versus fine-tuned models. And pretty much why I mentioned this is because I see a lot of topics about utilizing fine-tuned models, and I personally think that 99% of the organizations think they need fine-tuned models, but in reality, they just need RAG. So be careful of that, because if you go down the wrong route, you are very much more likely to drop that specific project, especially if it's fine-tuned model, because even the big companies are struggling of developing a high, consistent and reliable fine-tuned model. So you need to really ask yourself of what we are trying to achieve here. Now, fifth, the adoption ecosystem. Now, you probably see a lot of videos on YouTube, people solving problems with the AI, but in when you try to understand what problems they are trying to solve, you really understand that they don't really need AI in the first place. One example I can give you is we had one organization that they wanted to implement AI in their day-to-day workflows, and they wanted to create a certain specific automation. Literally at the start, I already knew that they don't really need AI. They could just literally conduct and develop that specific automation, specific solution with simple logical statements, if else, and that's basically it. They didn't really need AI in the first place. So how you and the biggest questions that I get on my sales calls and people asking me is, where can I implement AI? It's not about how to build it. Of course, that's the next step, and people are struggling with that as well. But it's more importantly, where should I build AI solutions? And a lot of people are trying to find a YouTube video. Okay, this guy implemented this. We need this, but that's a completely wrong approach. The best way to implement AI solution in your business is to map out your business processes first and look at the friction points, which we call danger zones. Meaning these are the danger zones that are super important for your business. Meaning if they're not done, your client results are not gonna be shown. Basically, your client's not gonna get results. It will be a lot of delays, and it will just break. Meaning these are super important point in your whole business process. Let's say, for an example, for an insurance company, it could be quality assurance, meaning when they're checking damage for a specific accident that happens, they need to assess the value of the damage. And for that, right now, that's been happening. That required a human intervention. Human had to go and check the specific cases and see approximately what's the damage for that specific case, right? And what was that problem? Because humans would spend a lot of their time on very, very, very low value cases, but on the very high risk cases, they would not be that focused. They wouldn't understand, or they would probably just get missed, right? So let me go back to the point. Basically, how to find where to implement AI is to map out your process and understand where are the most important friction points in your whole operations. That can be either requires human intervention, human decision processes, meaning it requires a human decision making, and there are basically, in short lines, very important processes for your organization. And these are the processes, okay, the points where you can implement AI agents or solutions, right? And next to it, you will also see where you can just implement simple automations and simple autonomous processes and other technologies that you can get. Now, the other point when I say here adoption ecosystems, one thing that we noticed is that if you build an AI agent or a solution, just like another app, another tech for that specific company, which basically when you do that, you are simply establishing another process, another friction point to happen. And a lot of times those solutions don't simply get adopted because it requires a user to go to search for it and use it. And what we found out that the best way to implement AI agents and solutions is to basically embed them natively directly in their ecosystem. That can be either Slack, chat apps, CRMs, project management systems, and so on and so forth, right? And then one example I can give you is that we had built an AI agent interface, which is basically a custom AI LLM which interacts with multiple other agents, solutions, tools, and so on and so forth. And we have built it on Streamlit. And it worked well. It's been used, but one thing that we found out that once we switched to interface being Slack, meaning the AI agent can be accessed throughout the Slack and is connected to the other tech stack, to the other tools in their whole company, it got 100% adopted. Meaning it got adopted to that degree that every single employee in that department and other departments started using it, which is basically the goal what we're trying to achieve. And how we go about building AI solutions and get them adopted is basically the first few weeks, let's say from 1 to 3 or 1 to 2, as fast as possible, we develop an MVP, which is already working solution, aka alpha version. We deploy it to the end users so they start using it. Then we go through a phase which we call iterations and feedback, which is basically a closed loop between end users and our development team. And we try to understand, okay, what's working, what's not, and how to improve it. And the goal is to reach product maturity stage, which is basically a stage where a product gets adopted 100%, delivers a quantifiable result, either that be saves time, save cost, whatever it is, and gets adopted to that degree they cannot simply live without it. Meaning, let's say that specific multi-agent system, a solution that we developed for a content agency, got adopted, that they cannot simply live without it. Meaning these are crucial tool in their whole business because it saves them so much time, it saves them so much cost, they don't need to hire another strategist, and so on and so forth, right? So basically that's how we go about implementing and adopting AI solutions. Sixth, prompting. Now, here are the 4 steps regarding a prompting that you probably didn't hear before. Now, LLM loves simplicity and specific, being very specific, meaning let's say if you say to an AI, explain AI topic about me, about overall, but if you say explain AI to a 12-year-old in 3 bullet points, it will deliver exactly that. That's one of the reasons I always say AIs love JSON. Second one is don't let AI to think without guidelines, meaning think as a scientist. Let's say you give an AI the input to think as a scientist, or you give an AI the input think as a scientist following step 1, step 2, step 3. Basically break down complex steps into smaller ones. The third step is don't forget about formatting. This is especially crucial when building AI agents because the final result it might not look the best as you think. That's why you need to tell him to utilize markdown, headers, bullet points, bullet sections, like utilize hashtag for titles, use 2 hashtags for subtitles, use bullet points, and so on and so forth. The fourth, never assume AI knows what you mean by best or biggest. And that doesn't mean just for those 2 words, but overall. Basically, you need to clearly explain, okay, I want you to do best tweets. Let's say, give me top 5 best tweets from XYZ username. And by best, I mean the with the highest view count or top liked, whatever it is, right? Always provide context with. Now, regarding prompting, there are 2 types of prompts: task prompts and agentic prompts. Task prompts are basically simple prompts for a very simple specific task. Let's say extract the Twitter username from the given text. Rules: only return the usernames, example Elon Musk, no explanations or extra text, just the username. Meaning the only job of the LLM is to provide with one simple task, and that's basically it. And this requires minimal context, requires clear outputs, and it's optimized for speed and cost. A lot of people call them also short prompts. Now, for agentic prompts, it's a little bit different. This is used for decision making, workflow orchestration, handling multiple tools, pretty much when developing an agent that requires a system prompt, right? This is not for a simple or one-step tasks. And here is an example, a live example of our orchestrator agent, which is basically a supervisor agent, which the goal is to take the user input and the call correct tools and basically pass that user input to the next tool, either that be a SQL agent, a RAG agent, whatever it is, right? And here's how it works. The first part, you need to tell him what role, aka persona, to have, or a task. Meaning, let's say you can tell him here, you're an AI orchestrator agent responsible for classifying your user queries and selecting the optimal agent or tool to execute each request efficiently, Now, if you cannot give him the role or persona, you can just give him the task. Let's say you are the best at analyzing the query intent and determining the best way to process it. Now, a lot of people will tell you give him a role or persona, but what I see sometimes happening is that if you give him a role or persona, the AI agent, aka LLM, won't really understand of what that means, or they might not really understand what you want him to do. If I tell him act as a financial analyst, there are so many variations of financial analysts for, I don't know, specific industries or whatever it is, right? So you can make, or you can test those two prompts for yourself. Basically, either give him a role or a task. The second one is basically the task. You give him the task. In short lines, you always start with the goal, meaning your goal is to analyze the user query, determine the appropriate agent to handle it, and return a structured JSON response. Then the third step is you gave him the context. You are orchestrating multiple agents to specialize in different tasks related to the Twitter data. Meaning you must ensure that each query is assigned to the most appropriate agent based on the task type, meaning previous interactions, previous conversation history, and current query, right? Basically, why this is important to provide situational awareness. The fourth are the basically steps, meaning because this is an agentic prompt, you need to basically break down the complexity into very simple terms, meaning step 1, step B, step C, step D. Here's an example. 5, you need to explain every single available tool agent that they can choose from. In this example, let's say SQL for database queries about Twitter metrics, and in here you need to think of how the user will input the user input, meaning are they going to utilize specific keywords or how they will go about it. 6, decision rules, meaning if the query includes generate, create, or write, utilize this specific tool, and so on and so forth, right? And let's say here, complex multi-step queries, you need to give him an example of how to return it. Let's say I give him an example of how to return inside of the JSON format, right? If you utilize, you need to return it in this format. If it's for SQL, you need to return it if it's RAG in this format. If it's, let's say, a complex one, you need to return it in this format, and so on and so forth. Basically, you give him the examples of how to return it, right? This is basically it. You can also include notes, but that's optional. But here's an example of literally live example of this classification prompt and how this works. Now, the best way to go about prompting is to start small, test, and add. Don't add one big prompt that you found on the internet and then just run with it. No. Start small, add, test, and so on. Basically create a loop R&D approach about prompt engineering. So that's basically it. Now, one thing to mention here is you don't need to follow every single one of these steps here. Of course, if you can, that's the recommended approach because that's what we follow and works amazingly to provide the most reliable and consistent result. But with some specific agents, you might not need every single step, right? You don't need to complicate stuff. So that's why I always say, start small, test the prompt. This is the result that you can get, and then you go about it. Basically, that's going to be probably the most time-intensive time spent when building custom AI agents or solutions. So that's basically it. Now the 7 steps, tools and technologies. Now, when building specific AI agents and tools, you can either utilize no-code tools like NA8, which is built on top of LangChain, and they're great for quick development, MVPs, proof of concept. Now, the problem with the no-code tools is that you are basically creating them and they're limiting your development, meaning rather than developing how you think it's right and what's the fastest way, you're basically forced to follow their capabilities. Now, majority of our AI agents and solutions are built by code by utilizing Python, LangChain, Pydantic, Streamlit, Flowise, and so on and so forth. We also utilize no-code tools if we see the possibility, and that's the fastest, most feasible route to go about. But basically, in short, that's what I'm trying to say is choose the best one that you can build upon it. It's scalable and provides the best and consistent result. That's one of the reasons why you need to follow the first step by mapping out everything so you understand what specific tools and technologies to utilize when building this. So basically, that's the quick summary of it, of the 7 key best practices or mistakes that we've done in the past, or basically, or the learnings from the 2,000 hours of building custom AI agents and solutions. So if by chance you want to implement AI solutions, AI agents in your day-to-day workflows for your organizations, we are offering a free feasibility study where we will map out your whole business process, we will identify danger zones, and we will provide a list of AI initiatives, solutions, agents that you can implement straight away that align your core company objectives. Basically, this is how it works. We map out your whole company process, we uncover danger zones and inefficiencies, we understand what are your top priority challenges, goals that you want to achieve, and then we give you the list of AI agents and solutions that we are already proven to work, that we already developed, that you can literally just implement them straight away to gain an edge in your marketplace. And we do that all for free. Okay, you can book a call with our team for a free feasibility study. You can also check our other videos on YouTube channel, and you can check us on Twitter and of course LinkedIn. So if by chance this is relevant to you, let me know and see you there.